it's always about like human against machine, right? Okay, what did the human, what did the machine, right? Instead of like comparing it again, okay, we need a third group of like human plus machine, which can be faster and accurate.
Thank you for joining Hybrid Minds. Today, my guest is Dr. Leif Nissen Lundbæk. He is a Forbes 30 under 30 list maker and the co-founder and CEO of the next GenAI company Xayn that develops Noxtua. It's Europe's first sovereign legal AI. He studied economics, mathematics, and software engineering in Berlin, Heidelberg, and Oxford. He received his PhD from the Imperial College of London. Welcome, Leif. Thank you for doing this.
Many thanks for the very nice invitation.
Can you tell us a little bit about your company, what you're doing?
Yeah, sure. Well, Xayn itself is very much like a research company. And fundamentally, we develop Noxtua, which is, as you already mentioned, a legal AI, or more precisely, a legal language model. So we developed this together with partners, especially on the legal side. And we focus very much on the European side. So mostly Germany, France, also Italy. And we work together with these partners to build up a very large data set on legal texts, and based on these legal texts, developing a language model that especially serves lawyers, so law firms, legal departments, government departments, everyone who really works with legal texts. And so we try to build a system around it, help them automate a lot of their processes, and really be like a legal assistant for them.
I saw some of your articles and comments, and I know that you are very much vocal about privacy. And I understand that in a legal context, that's of course important, but do you see this as an important factor because of the industry that you're in, or generally as an important factor for businesses to not overshare basically their data?
I think especially in the legal industry, I mean, like privacy seems always like a bit of like or generally privacy seems to be like a soft term, right? But in the legal industry, this is like, it has to be a given, right? And this is not only, in like, laws that everybody knows, like GDPR or so. But this actually is, has a much, much higher value because we have, for example, in Germany, professional secrecy. So professional secrecy is regulated under the criminal law. And we not only in Germany have that, we have that in Austria, Switzerland, Italy, France. And that actually means that if you essentially share legal data involving multiple parties, and you share this, or for example, publish this somewhere where it should not be, that this actually is a criminal act. So therefore, it's like much more severe than just privacy. So if you want to develop a solution that serves the legal industry and serves lawyers, and especially not only serves them on, let's say, a database level, but also on an operational level where they, for example, load in very confidential client contracts and work together with these client contracts, and especially in an AI scenario, well, then professional secrecy and therefore privacy and compliance is very much like a given. It's not like something you can ever debate about. This is a given, and then you can think about how to develop solutions on top.
But then how do you train then these models, right? Because you need lots of data to train it. Are you synthetically generating great data, or is it partnerships that you generated the data from?
We very much operate in partnerships on the base level. And then we extrapolate the data with synthetic data, because often this is just not enough, right? So, but mainly, I think, and this is maybe counterintuitive, the data privacy is a lot less of a problem when it comes to training than it is for inference. So for training, you usually develop very specific contracts with partners. So everything, and I mean, we have to work together with lawyers, and they love negotiating, right? I mean, so you can imagine how fun that is to get to an agreement. But anyway, so let's say if you go through all of that and you essentially have some data, right? I mean, we have to maybe talk about what is data really, but let's say you have some data, then usually this is real data. So this is, for example, court decisions. This is, and I mean, like, people often think they are public. They're not really, at least not in Germany. So we only have like a very tiny fraction of court decisions and so on published. So once you have those, then you also need to think about like all of the different use cases that you want to serve, because like a lot of people, especially in this industry, think, oh, you just need to get a couple of court decisions and then you can build a legal model. Well, with court decisions, you first can't do anything, right? You need to actually have data that really tells you how is a contract structured, what is a good contract, what is a good drafting of a clause, what should a clause contain in different scenarios. So we actually had to develop data, so not synthetic data, but actually develop data together with our partners. And this is, for example, like just building of huge matrices of clauses in all of the different situations. So multidimensional clause generation, basically. And then once we have this, like a very, very good standard, then we extrapolate this and then we make out of 2 million, 1 billion or so, right? And then you can train. But this is also just to have like a basic understanding of law. So this is basically, let's say, going through a legal education, right? And then afterwards, you have to train how to talk to lawyers, which is also different than talking to, I don't know, like normal people.
Yeah, basically you have this human preference part at the end still, but you need to do that because of this law. Well, that answers actually my other question. So you think that a vertical AI is the thing to go because it's just too special and you need to train a separate thing, and a ultra large language model like, I don't know, Anthropic or ChatGPT couldn't serve it well enough?
I mean, this is of course like always the question, really. There is, I mean, if you think about ChatGPT, and by the way, ChatGPT is by far not the best in law, but I mean, from the large language model perspectives. But anyways, if you think about those, you think, I mean, they invest so many billions and they get like bigger and bigger. They probably will, I mean, like dominate everything. And to a certain degree, they can, of course, do the job. But one thing that we saw actually in benchmarks, and especially when it comes to benchmarks here in tasks that are relevant really in the day-to-day life of lawyers, is that the newer the model gets, the worse it actually is in legal tasks. And this is so the bigger and newer they are, they actually don't perform better. They actually perform worse. And so we were actually very surprised to see that, because we were doing blind tests. So Noxtua 1 and Noxtua 2 against just the normal models, GPT-4, Claude Opus, Sonnet 3.5, Mistral Large 2, Mistral Large 1. And it was really, really surprising to see that Mistral Large 2, for example, was only half as good in law as Mistral Large 1. I mean, in legal tasks, right? Not in law. I mean, you wouldn't ask a model to whatever cite law X, Y, Z anyways. But really legal reasoning, right? So it actually gets worse for the newer models. And this is really, really, really counterintuitive, actually. And we, of course, also, we don't know 100% why this is, but our best intuition right now is that mostly because all of these companies battle each other in open benchmarks, right? So there's very specific benchmarks that matter in the world. And a lot of that is like, I don't know, coding challenges, math challenges, whatever, right? All of those tasks, right? So some kind of like chat arenas and so on. And what do they do in order to achieve that? Well, all of these companies, they hire large teams somewhere around the world in order to train the model. So generate a lot of chats, like, for example, OpenAI with a new project, Strawberry, also now generates artificial interactions, right? But they all, of course, want to focus on this specific area in order to be the best, right? Because then they can report back to the investors, hey, we are the best in whatever, this and this and that. And of course, it's important to make them comparable, really. But the problem with that is, of course, that all of these tasks and these benchmarks are so far away from the daily lives of lawyers and what is important on the legal tasks, right? So where it's about completely different reasonings, right? So basically, legal data doesn't get more. To a large extent, it's actually proprietary. So they don't even have access to it. While all of the other data becomes like gigantic masses, because often you can just generate it. You can generate math challenges. Code, I mean, like code is something that is like inflationary there, right? And it's big. It's a big business, right? I mean, like if you can replace developers. So I imagine this is like something that they invest a lot in. But for lawyers, this is not a good message. So therefore, we very much believe that there is a lot to it. And we also see that our competitors and our main competitor is Harvey, right? Also, they publish such benchmarks where they see like they actually perform better than ChatGPT and whatever Claude Opus or so, right? It's really, if you train on something specifically, you can actually get better results.
I don't know, to be honest, the size of your language model, right? But what's your stance on LLM versus, small language models and compression of language models, quantizing, or, other forms of compressing them versus, this ultra large that, tends to reason better than smaller ones?
It's of course very hard to say what is small and what is large here, because like these dimensions, they change monthly. And when I started developing language models, I mean, small meant 1 megabyte, right? And large meant I don't know, maybe 100 megabytes. So now if you tell someone I have a large language model with 100 megabyte, right? I mean that fits on your smartphone, right? I mean, like. Back then also 100 megabyte didn't fit in your smartphone. So therefore, the relations are very different, and our models also got like way bigger, right? So, and also we know obviously, I mean, if you have more parameters, you can store more, you can train on more data. Also data, I mean, we generate a lot more data, and also like every time we train, we have more data at hand. So, and we also try to extrapolate that and generate really a huge amount of artificial data because we see it leads to better results. So therefore, this is a very important topic, but therefore it's like even if I say now, okay, this is large, then I don't know whether this holds in 3 months.
That's very fast, yeah.
Yeah. And generally my understanding is more that this has to be economical, because you have to think about, okay, what is the willingness, to pay from people? What is it? How much is it worth replacing certain tasks? And then you can, then you get like a specific number. Then you also have to see, okay, what is the competition charging? Right. So for example, on legal tasks, it tends to go or flatten right now around, let's say 100 euros per month per user. And then, okay, this is like a rough volume of what they interact with. And then that number you can take to see, okay, how large can you go now? And obviously you go rather larger than smaller. And, because you want to deliver the best results, right? And therefore, based on that, and certainly you need a specific margin. So therefore, of course, you also need to kind of use that in order to maximize the accuracy while minimizing the cost. Obviously, quantization, something we do heavily. A distillation for specific tasks, yes, right? So oftentimes it's important to kind of split the system into different aspects, create multi-agent systems, right? So something that I can talk about, for example, now is like our developments on legal research, where we develop legal research or Noxtua research with partners. And this is actually a multi-step system where we try to kind of identify first the best sources. And we, for example, also trained Noxtua Voyage together with a spin-off from Stanford University now to specifically identify the best legal texts, also performing roughly 2.2 times better than the best OpenAI model in that, right? So it's a huge leap forward and being like, I think 3 times smaller than their best model on that size. So yeah, I mean, we try to do that because it's like we have to operate on large amounts of text. We have to identify these texts. And then we do it in multiple different steps to kind of see, okay, what is the best data to take in? And then it gets smaller until you put it into the very best legal model on top to generate really the answer. Because there, the reasoning side is, of course, the most important. And we know the bigger you are, the better you actually deliver reasoning if you are trained on this legal reasoning side in the first place.
That leads me to two questions that I would like to ask. On the reasoning side, I'm interested to know what your stance is on knowledge graphs, because more and more companies integrate it to their dense vectors. Basically, Microsoft came out with GraphRag, and there are other companies that are very, very vocal there.
Yeah,
and the second one is going to be about agents, but let's start maybe with the knowledge graphs, and then we move on to agents.
Yeah, maybe to just say it quickly. I mean, we do a combination of everything because it is such a complex task that also humans don't get it always right. Otherwise, we wouldn't have legal disputes, right? Because if you knew, then I mean, you don't even have to go to court. All right. So therefore, I mean, okay, you can try maybe, right? But it's, so therefore it is just an ultra complex task, right? And if you talk about like something, okay, like on easy questions, you should of course have like whatever 99% or 95% accuracy, right? But the harder the tasks get, there's of course like, there's a lot of information around and you need to put everything together and so on. So therefore knowledge graphs definitely make a lot of sense. But one particular problem with knowledge graphs is that they are hard to maintain. So you really have to, it's quite expensive to kind of, recompute them all over again. And things change a lot, right? I mean, legal is actually not like a static thing as many people think, but there's a lot of new court decisions coming out. And, also law is not just like, okay, we have a couple of laws published or law books published, but it's a lot about court decisions, commentaries, and so on, right? So therefore, if you look at the pipeline there, I mean, like it's so big, right? So the LLM part is like tiny, right? It's a tiny little bit. And therefore, yes, knowledge graphs definitely help a lot. And also, ultimately, it's a combination of everything. It's dense vectors, sparse vectors, exact match search, it's generating queries, thinking in different edges, right? So you see a task, you don't like push just this question into the database, but you think about it. You think about, okay, in what kind of corners, in what kind of directions could this go? Do multiple searchers, put everything back together, analyze it. Could you still do it? So you do multiple different hops, right? And you do multiple different agents, which, so I already go now into the agents topics, right? But yeah, anyways, yeah, makes sense. But on the agent topic, I'm actually a little bit less optimistic than when it comes to knowledge graphs or so, because it depends a bit on the task. I mean, because multi-agents usually have a bit of an impact on the usability and on the UX side of things, right? Because the user at the end has like a small bar, types something in and wants to get a result, right? Perfectly researched. So, and the more you have a multi-agent system, the longer it takes really, and so it's not really fast. And often if you have like these multi-step, agents where first different agents go in different directions, then you put those things together, let them debate or whatever, right? And put again, like the result in the next agent takes way too long. So therefore, we do that. So we have multiple hops, but only to a certain extent because it just tends to go too long. And, yeah,
I agree. I have made this experience too. Like if you really let it do whatever it wants to. It doesn't matter how much you restrict one, like one gets a crazy idea and then it drags the whole conversation into that direction, basically. So you have to be very careful how you design the conversation. I think that you need to, if you use agents, you really need to put a lot of effort in conversation design, like who is allowed to talk with whom and about what.
Just as a small addition, I think that it comes in the beginning and at the end. So, and the most important topic, obviously, so is the search, right? So, like, it's like as a human, if as a human, if I would research something, I would try to first think, in which directions do I research? So I take those directions and each try to gather as much evidence and data, whatever literature as possible. And then I connect all of this information again and try to come up with an opinion, with an answer, whatever. So, and that's, so therefore I would try to shy away from like different voices and whatever. I mean, this kind of thinking comes, of course, a bit from kind of group work, right? So, but I mean, it can also turn out like group work and it can hold you back.
Yeah, that's true. That's true. Yeah, I agree. And I think there's also the reason why, like LLM compiler and these recent papers are very much about how can you well parallelize this, right? Because if you don't parallelize it well, you end up exactly in the scenario that you said. You ask a question, it goes on for 20 minutes and then comes a wrong answer. And you go like, and then if you look at the conversation, you see it had like 20 times the right answer, but then it settled on the wrong thing. And then it's like very disappointing. Yeah. Yeah. But nevertheless, I think it's still a big trend, right? I mean, and the other big trend is really about context window sizes, right? So, I mean, you see there's a whole race on making that larger. And of course, that gets very fast into billions of dollars. What's your stance there? I mean, how important do you think it is?
It's, well, in law, it's of course super important. So this is like, I mean, it depends, right? And like an NDA is maybe, I don't know, 10 pages long, right? I mean, like that's easy, but everything in real estate, for example, is like hundreds of pages, like 400 pages, 1,000 pages easily. So, and that's of course something you can't do with 128,000 token as a length. And this is right now where Google has with Gemini 1.5, like of course a huge advantage, right? So I would say they are right now by far the leader in when it comes to really, really, really good context length, but also good accuracies. And keeping the good accuracies, for example, in like needle of haystack tasks and so on, even on a window of whatever 1 million plus. So this is, of course, you can load in entire books, right? So this is like pretty good. They have other challenges. They are like less good in like reasoning and so on. So therefore, and especially on the legal tasks, they're not particularly good there. So, I'd love to, of course, get access to this kind of, tech. But this is like they really know what they're doing there. So this is, I think, amazing. But otherwise, I mean, we right now, of course, go also try to extend the context length. I mean, we have, of course, our training data is usually long. So therefore, this is like something we can do. But it's also very, very tricky, right? I mean, like, because you need the right machines, you need to, it blocks a lot of processes and it's very, very hard to go like past whatever 200, 300,000 K. Because then again, also, if you go longer than that, you need again like books or so, right? And Google has, of course, like a perfect data set for that because they can basically leverage their access to books. Now, of course, the alternative is also that you go into compressioning and that you try to kind of combine, use basically document in a RAG style. But that, of course, has impact on the accuracy, a lot of impact on the accuracy. And especially if you want to really, you need to operate on the entire context window, so on the entire document, for example, and have like very complex tasks there. So very, very tricky topic indeed.
But what is then your stance about the attention being not constant along the context window, right? Because I think that has been well documented that many cases the attention goes down in the middle. So then you have this problem that overstates the beginning at the end, basically. And that seems to be like a difficult problem to solve.
Yeah. I mean, that's what I meant. For example, where like Google is like amazing right now in their accuracy, so they really keep that. So where, for example, some other players which really were in the forefront first, like Cohere, for example, that really have this problem a lot, right? So like they theoretically have 128K, but I think they can. I don't have the numbers on right now, just right in front of me, but I think after 60,000 plus or so, it's going really down, right? So it's a difficult problem. Yeah, I mean, we try to tackle that a lot, and we of course have like a bit of an advantage that we know what our data looks like and what kind of tasks we have to perform. So therefore that is a bit of an advantage, but it also is very much an ongoing problem. And we are very, very much, still having like problems when it comes to really past 100 pages or 150 pages or so in, contracts. So this really is still a problem.
And what about, using RAG technologies and these kind of things? You think it's difficult to combine the right chunks and come to a right conclusion in such a scenario?
Yeah, it depends on, right? So if you do like one-shot tasks, then this performs pretty well. So because we trained now also like this legal model specifically for searching the right parts, and we can actually do very big chunks. Because the big problem is, of course, especially when you look at contracts often have like the same topic in different places. It might sound very similar, right? But it's actually, you need to find a very specific part. So therefore, the overall accuracy is better keeping the entire document in context space. Now, if you can't do that and you have to do RAG, then we found it's better to do this on much larger chunks, because you increase the likelihood that the right information is in that in those two, whatever top 3 chunks. That's right now how we address it. However, now if it comes to kind of multiple step combinational tasks, then this still is very much a problem, because like the first question might be fine, right? So one shot, right? But second thing, you might want to combine the result that you had here with something in a completely different chunk. So of course you need to research again, but you also have to combine this with whatever you have found before. And then again, you very quickly run out of context length. So after like whatever step 2, step 3, you're out, right? So that's a bit of the complexity here.
And then when we talk about context length, we always assume that there's just one context length, but in reality, most of those have a context length for remembering things, but then the output context length is much smaller actually, right? So if you look at even OpenAI or something, they have like 128,000 in GPT-4o, I think, and then only 8,000 tokens in output length.
Yeah.
How do you think about that? Because I could imagine you're doing summaries and texts and other things, so you need actually a larger output too, right?
It depends, right? I mean, like, of course, like for like summaries and like, for example, I mean, mostly or most of the legal tasks are, for example, analyzing reports, analyzing contracts and generating reports. And these reports easily are fitting in whatever 4 or 8 or whatever thousand context or output context length, right? Or that is no problem. But of course, if you want to generate a contract, and especially if you want to generate a larger contract, then this still is very in the daily tasks that we see. However, mostly it's about drafting clauses, modifying clauses, analyzing contracts, doing legal research, and not writing a contract completely from scratch. I mean, some may do that, and then usually you anyways, start with a shorter contract of like whatever 10, 20 pages, which is doable. Like the reason that we have contracts that are whatever 200 pages long is mostly because there is like multiple step of negotiations. And these contracts tend to be older. Like when, I don't know, Xayn was founded, I don't know how long the contract was, like, I don't know, 10 pages maybe. And now I think we have like a 300-page shareholder agreement, and that wasn't done by us, right? So this is like, that was like multiple investors trying to agree on something, and that's how it happens, right? So therefore now, of course, it's not like that we would just write a new shareholder agreement. Well, maybe we do, but I mean, you would just try to analyze that contract, try to bring it on a point. You might want to modify a couple of clauses, optimize a couple of clauses, include new clauses based on the contract, things like that. And that's doable, right? Nevertheless, I mean, we are really in the beginning still, right? And there is a lot of new features, new developments that have to be developed. And some are possible, some are not yet possible.
What's your stance on languages like German, English, I don't know, French and so on? Do you train specific, or do you like have one for different languages?
We treat them all at once. We of course have to prioritize, and there's a couple of important languages for us. Generally, German is right now the most important, and English comes next to it really. And then we have like French, Italian, Spanish, Dutch as languages that are very important for us, and also Japan, because we have quite some engagements in Japan. So therefore, that's that. However, we look at it more from a perspective of jurisdictions and not languages, and languages basically follow jurisdictions, because here we actually see very, very good benchmarks in legal translation, which is something that just comes as a side product, so to say, side feature, without like focusing specifically on it. Because you have, like, for example, all of the different court decisions on EU level, contracts, etc., on EU level with perfect handwritten translations. So this is something that is like really, really a good source. It's a great source. And also law firms often operate or interchange their languages. They might use it in German, but treat actually an English contract, so in the English language, or the other way around. They often have like side-by-side translations in contracts that is used a lot, and that helps also a lot. And it's like, for example, in legal contexts, it's very hard to use tools like Google Translate or so, because it's like so much is contextual and so much has like so specific words that means something completely different, right? So for example, in German, it's like you might translate ownership in like Besitz, but then you have like in German also Eigentum, which means something completely different than Besitz, right? So it's like very hard, right? So you need to have like these different relations, and this is something that we learn a lot with training on these different languages.
Yeah, I imagine that's really important, right? Because on language on the street, nobody makes a differentiation between Besitz and Eigentum. But in reality, legally, it's a huge difference, right?
Yes.
It's a very big difference. And what do you think about, because you were talking also about handwritten things, so that's why I'm asking this. And so there is more and more the trend going now, not doing OCR, but having a multimodal model that would interpret. Right? I mean, there are a few things, we are also doing somewhat those things, because what we are doing is very layout intense, so we need to do it. Yeah. I imagine that your documents are not very layout intense, but if it comes to handwritten things, it might make sense. So what are you doing on that front? Are you multimodal, or are you just relying on other technology for that?
No, up to right now, we are relying on other OCR. So we haven't done that yet. And still haven't really completely made up our mind on that yet, to be honest. However, I think the trend is indeed, as you say, very much going multimodal, and then like directly taking that in. Like you basically cut one step, because you load it in actually anyways in the a vector. So therefore, why first, like, because you have like, I mean, otherwise the LLM is only as good as the OCR. And as far as we see, the results tend to be a bit better multimodal. So probably we're going that direction as well. But we haven't done so, up to now.
I imagine that for you, it's not going to be huge of a difference, but yeah, it's just that the compute necessary is quadratically increasing, right? So it's not like linear. I cannot take the OCR model and this model. So okay, together they need that much, fine. But now in reality, it needs like really a lot, and that tends to be sometimes a problem.
Which comes back to the economical question, right? So at the end, it's an economical question of like how much accuracy loss can you afford, but also how much price increase can you afford. So I mean, in that regard, we are very German. So we try to like not kind of dump it completely, and but rather think, okay, we need this kind of margin and be realistic and so on. I mean, also we can do, because of course lawyers have like or have a much higher willingness to pay than like the average person on the street having to pay for ChatGPT. And there, I mean, like I can imagine actually like that can't be profitable.
Yeah, I mean, it's public information. I don't have any private information on this, but I mean, I think 5 billion this year. I mean, I talked to one investor who told me once, it seems like it's a philanthropic investment, not really an investment for getting.
Well, someone has to bring it forward, right? So that's good. But yeah, it's like, it's kind of true, right? And but it's of course also to get rid of competition. That makes sense.
I mean, that's the strategy, right? The strategy is just the way in markets where you bring down the marginal cost that much, right? You need to grab a lot of not you need, but it's natural to grab as lot as you can out of the market, because, marginal cost is basically the lowest price that you can go.
Yeah.
And that's what they're doing. And then there's, of course, the whole fight around, computer chips and training hardware that you need to solve with this. So,
yeah,
I'd say it's a big, almost war going on, I guess, on this hardware chips right now. Let me ask you about tools, because that's like the last big trend, right? We have context window size, then this agentic system, and then many identify tools as a very big thing. So connecting it with other things, right? So connecting it with the internet, connecting it with an API to do something, connecting it with other things, and then let it, tab into where it needs to. What's your stance on those things?
I think we already use tools a lot, but I mean, like without like being so, I don't know, like focused on saying, oh, we do like whatever tool use. But mostly for us, it's very clear, because for us, a tool is basically a different data bucket or a database. And so we talk to that database, and that is like essentially a tool use, right? It could be the internet, right? As in whatever, connecting it to an API at whatever crawls things from Bing or whatever, right? That in our scenario, it's we connect to different tools. So we have partnership, for example, with De Jure, which is one tool. We have then our own semantic buckets, basically, where we connect to and where we do like a search in, essentially. And then we have multiple different other connectors. So you can like whatever connect to your own database. You can add whatever like other legal databases as a connector. And then like our system talks to then basically these different databases. But I find it like as a pretty classical scenario. So nothing very special.
Yeah, true. Many things are, right? I think the only special part of it is that it needs remarkably little coding ultimately, because it can, be not as precise as coding language used to be. It interprets it basically and then connects to it ultimately.
So in a way where you have like these, so probably you're referring a bit more to the, like, let the LLM decide which tool to use,
yes.
right? Well, okay, that's that's a good point. We are experimenting with that, but our results right now by just really directly encoding basically connect to these different buckets and let the user decide right now leads to a much better accuracy, but also and this is in legal, I think, very important. Repetibility. So it's like every time the same result. If the LLM decides which tool to use, we actually saw that the results tend to be different every time, and that is also in legal research is a very, very bad thing. In general, our focus is a lot on exact citations, repetibility, and accountability and these kind of things, right? So very boring topics, but they need to be like, if you run it 100 times, at least 99% of these times, it should be exactly the same result. And therefore it's a bit more boring, but it's about like being exact, being reliable. And this is like just different values that are important in law. So therefore I think we can be, unfortunately, not as cool as what you can use with like systems that can decide on their own whether they go whatever, this time go fishing and next time they go hunting or whatever, right?
Yeah, I see that. I mean, I don't even think that's boring, actually. I think that's exciting in the sense of it's a hard problem ultimately that you're trying to solve because I mean, my personal stance is on those things is that hallucination, which often contributes to those things, is actually the biggest feature of an LLM and not a bug. But at the same time, you don't want it to happen on your question, right? You want it to happen in the creativity to find a solution, but you don't want it to happen in these things. So, and that's very hard to achieve, obviously. And that's why I think it's actually not boring. It's actually a hard problem to solve and an interesting thing that you're tackling. And yes, I agree. It's very important for you because you actually really need to show something that's right. I think there was a case, right, in the US where a lawyer generated something with, I don't know what LLM, but then went to present it in court, and it turned out to be.
Yeah, it hallucinated the entire whatever, some artificial decisions and so on, right? I mean, but it's like I would call this a forced hallucination. I mean, like that was just pretty stupid. And but I mean, I imagine for you guys it's very similar, right? I mean, like coming from like in the whole financial industry, it's more or less. It's like probably also like medical industry also maybe not so nice to kind of hallucinate a bit, right? And
Absolutely.
This time you take out the heart, next time whatever the brain. So that's probably also not great. So therefore that should have like at least a bit of like repetibility plus of course human oversight.
Yeah, that I think is very important. I think this human oversight is an important part there. Maybe call it the hybrid, and that's also the title of this hybrid intelligence, because I actually think that the combination of these two leads to a better result. So I'm not even, and that I think is something that's going to stay for a long time. And I think it needs to stay for a long time because our values can be mimicked by AI ultimately, but our values are changing. So it means there's always going to be a race of, what are our current values of things, right? I mean, and I think that's why I think it's very important to have that in our, pipeline of things that we're doing.
It's also so funny, like that a lot of the times, and I mean, I see this also with customers and so on, it's always about like human against machine, right? Okay, what did the human, what did the machine, right? Instead of like comparing it again, okay, we need a third group of like human plus machine, which can be faster and accurate. We also did actually such tests at CMS, for example, and this group outperformed both groups by far, right? While like humans, and I don't remember the accuracies and like also without seeing the data doesn't say anything, anyways, but I think it was like at least 6% points difference or so, right? So something like machine only 91, human maybe 93 or something, and like machine and human 98 or so, right? So I mean, but don't take.
And what people are not seeing there is that in all those numbers, right? If we take those numbers, what people are often not seeing is they're saying, okay, look, it's like 4 percentage point better, right? But in reality, it's the error just half or even less than half of it, right? So it's actually huge step forward if you combine these two with each other. Right?
Yeah.
And I agree. That's very important. And I think it all starts even with the definition of AI, right? I mean, even Turing's definition already goes about human against AI, right? Because you go like, can you hide it? And then even that part already is a competitive scenario rather than thinking of, wait a second, we can actually more augment and more, work together or cooperate,
And a lot of the benchmarks today also, right? I mean, like a lot of like whatever the alpaca, etc. It's like all mostly human written against machine written.
Thank you very much. This was very, very interesting, Leif. You're doing great stuff. I think your focus on you said we are very German about this. I think actually there's already going on a big awakening in many companies that they realize AI is great, but you actually need to deliver value with it. It's not just enough that you do it. So I think you are on the forefront of those things actually. And this awakening is, I mean, we see it in our industry very much so.
Yeah.
I congratulate you on all your success. Very interesting. Thank you very much. And thank you for all your insights.
Likewise. Yeah. Many thanks for the invite again. And it was great to talk to you.